handout that I gave you yesterday. We're going to do it. You probably need a calculator, right? So, first one, during fifth period lunch, 85 of the 280 students had milk as their drink. Based on those results, how many of the 1,390 students at work would drink milk, right? So first, we can write that 85 out of 200, right? 280 students, right? Had milk as their drink. So we can take that ratio and multiply it by 1,390. So 85. So we're going to put it as a fraction. And 85 over 200. 85 over 280 times 1,390. So this is equal to 400. I mean, if you simplify, you're going to get 421 students, 27 over 28. Well, you can't have a partial student, right? So we're going to round this in the context of this story to 422 students. A bag of marbles have 7 red, 8 green, and 11 blue marbles. So if you didn't write that down, can you please write it? Once you select a marble, it is not replaced. Remember, that's super important. We don't put the marble back. Okay? So what's the probability of getting a red? Well, first of all, we need a total. So 7 plus 8 plus 11, that gives you 26. So the total is going to be 26. Probability of getting a red is going to be 7 out of 26. Not green. Not green would be all the red and all the blue. So 7. So 7 plus 11 is 18 over 26. And we can simplify. This one we can simplify. It becomes 9 out of 13. Green or red. So anytime we see the red, I want you to put a plus sign. Right? So how many greens do we have? We have 8 greens. Right? So it's going to be 8 greens and then red plus 7 red over 26. Right? So we're going to get 15 out of 26. This one, red and then green. And then, but remember, and means multiply. So what's the probability of getting a red? All right, the red is going to be 7 out of 26 times, right, because and means multiplication. And now you take a red and you put it over here, right? Put it over there, leave it. Now if you go back in the bag, you want to get a green. Well, there's 8 green, but your total is not 26 anymore. Your total is 25, right? Because this red is outside. All right, so let's multiply this. 7 over 26 times 8 over 25, and we're going to get simplified. It's going to equal to 28 over 325. Okay? Three. So this one was a little tricky, right? There's a 30% chance of rain for Saturday, and there's a 60% chance of rain on Sunday. What's the probability that it will rain all weekend? Well, if you think about it, so let's write Saturday. Saturday, and then this is Sunday. So Saturday, there's a 30% chance of rain. On Sunday, there is a 60% chance of rain. So we want the probability that's going to rain on Saturday and Sunday, right? And what do we tell when we say and was multiply. Now you can't multiply 30% times 60%, so we're going to change this to a fraction. So I'm going to show it. Well, I'll show you how to use it on your calculator on Wednesday, but we can change it to a fraction and a decimal. Well, right now, well, 30% is out of 100, right? So we can write 30 over 100 times 60 over 100. And you can multiply those. So we get 30 over 100 times 60 over 100. And if you can simplify this, you will get 9 over 50. Next question talks about theoretical and experimental. So I'm going to break it up into 3 parts. Right? Remember what theoretical is, and remember what experimental. So experimental, experimental probability, you need an event to happen. Right? You actually have an experiment happening and you're looking at those results. Theoretical, right? There is no event happening. The experiment is not happening. So we're looking at the facts that we have. For example, on a coin, we look at a coin and we know there's 2 sides, right? And one side is tail, one side is heads, and that's how we determine the probability. Okay, so here's a coin. Maggie flipped a coin 20 times and recorded the results in the box below. So she got heads, tails, tails, heads, tails, tails, heads, tails, tails, heads, tails, 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 heads, heads, tails, heads, tails, tails, heads. So the question is, which one is greater, the experimental probability or the theoretical probability of flipping heads? Explain and use evidence. Well, on a coin, if you look at a coin, right? What's the probability of the coin landing on heads? Well, the probability of landing on heads, well, 1 over 2, right? A coin has 2 sides and one of them is heads. So the probability of landing on heads is 1 over 2. In the experiment, right? So we need to look over here. So this, we need to look over here, right? So in the experiment, how many times do we flip the coin? We flip the coin 20 times. How many heads did we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 20. Now, let's change that to a fraction, because the question is which one was greater, the experimental or the probability. So, sorry, change that to percent. So if you change that to percent, it's going to give 40%. And if you change this to percent, it's 50%. So which one was greater? The theoretical was greater. Okay. 5, there's 35 cars in the parking lot, right? We know the total, right? Here's the total. What's the 12 are black, 10 are silver, 5 are blue, 5 are white, and 3 are green. If 2 cars are selected at random, what's the probability that both cars are black? So, excuse me. So we want to take a black car and then another black car. So, what's the probability of getting a black car in the first try? Well, how many black cars? We have 12 black cars, right? So it's 12 out of 35. So we're going to take the black car, right? We're going to put it over here, right? Black car. And then we're going to go and take, remember the word and means multiply, so we take another car, right? We're going to select another black car. Well, if there's 12 cars and you put one on the side, now we have 11 cars. So the second one is going to be 11. And what's the total? 34. So let's multiply and simplify. So this one, 66 over 595. Okay. There are 14 candies in the bags. 4 are broken. What's the probability of reaching the bag and pulling out a non-broken? So you have 14 candies in the bag, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then this is broken, this is broken, this is broken, this is broken. So what's the probability of going into the bag and getting a broken candy? No, sorry, not broken, non-broken, one that's not broken. So we want these ones, right? What's the probability you're going to get these ones that are not broken? So, probability, non-broken. Well, how many in total, first of all? The total is 14. How many are not broken? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are not broken. And if you simplify, you get 5 out of 7. A survey was taken on students' eye colors. The results are shown on the table below. So 12 people have blue eyes, 58 have brown eyes, 2 have green eyes, and 8 has hazel eyes. It's a little bit different than brown. Okay. What's the experimental probability that a student has hazel eye color? Well, probability of hazel. Well, how many people have hazel? 8 out of, and what's the total? So we have to do 12 plus 58 plus 2 plus 8. So 10. That's 90 students. So we're going to go 8 out of 90. So that's 4 out of 45. So and then the question is, out of the next 400 students to be surveyed, how many of them will have hazel eye color? Well, now you know what to do, right? We take this guy here, 4 out of 45, right? That ratio, and we multiply it by 400. Times 400, 4 over 45 times 400. We're going to get simplified 35 and 5/9. Now you can't have 35 and 5/9 of a person, so this is going to change to 36. Okay. Maria flips a coin 20 times. The coin only lands on tails 9 times, according to the theoretical probability. How many more? Maria flips a coin 20 times. The coin lands on tails 9 times. According to the theoretical probability, how many more times would Maria have expected the coin to land on tails? So let's talk about this. Theoretical. If you look at a coin, what's the probability that the coin will land on tails? Right? The probability of a coin landing on tails is going to be 1 over 2. What is 1 over 2? 1 over 2 is 50%. So let's say you are Maria and you're going to flip the coin 20 times. Right? So if it's 50%, you're going to say it's going to be heads, heads, tails, tails, 3 heads. Right? It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10. So if you're going to throw the coin in the air 20 times, you're going to think it's going to be 10 heads and 10 oh my god, 10 heads and 10 tails, right? That's what you think it's going to happen. But in her experiment, what happened? She got 9 tails, right? She only got 9. So how many more do you need? So how many more would you expect? Did you expect to land on tails? Well, you were expecting 10, right? You got 9, so you expected 1 more time. Okay. Okay. Number 8, Marvin has 20 marbles. 8 are clear, 4 are blue, 5 are yellow, 3 are black. What's the probability that Marvin will randomly pull 3 clear marbles out of the bag in a row if he does not replace the marbles after he pulls them? So I think I'm going to try to draw this out. So 8 clear. 1, 2, 3, 4, 5, 6, 7, 8. 4 blue. 1, 2, 3, 4. 5 yellow. 1, 2, 3, 4, 5. 3 are black. 1, 2, 3. So 8, 12, 12 and 8 is 20. So we have a total of 20. Now he's going to take a marble and he's not going to put it back, right? So what does he want? He wants the probability of getting a clear and a clear and a clear. So 3 marbles this time, right? So what's the probability of getting a clear marble on the first one? Well, there's 1. So right, this is the clear. 1, 2, 3, 4, 5, 6, 7. So there's 8 out of 20. And means times, right? And now we want another clear, but this one is no longer there. So the second time when you go and get a second clear, it's going to be 7 out of, well, your total is now 19. So it's 7 out of 19. If you want to try to get another clear marble, well, again, remember, right? We got to take 1 out. So you don't have 8 anymore. You don't have 7 anymore. You have 6. And again, what's your total? 18. So now you're multiplying 3 fractions. Okay? So 8 out of 20 times 7 over 19 times 6 over 18. We have 3 fractions being multiplied, and our answer is going to be 14 out of 285. So very, very small chance. You can change that to percent. And if you change that to percent, you have 4.91% chance of actually being successful here. Okay, so there is a 0.05 chance that we will have an earthquake this year. What's the probability that we will not have an earthquake? All right, so one thing you can do here, if it makes it easier, is change this, right, to a percent. So if you multiply that by 100, right, you're going to get 5%. Maybe that's a little bit easier to understand. If there is a 5% chance of having an earthquake, what is the chance of not having an earthquake? So 5% chance of having an earthquake. So that means, remember, probability, we measure it from 0 to 100, right? If you have a 5% chance of having an earthquake, that means you have a 95 chance right? There's a 95 chance of not having an earthquake. Of not having an earthquake. Let me talk about that again. So let's say, let's give you another example. Tomorrow, there is a 10% chance of rain. 10% chance of rain. Is that a lot? No. You know, so very little, right? You probably don't need an umbrella. So if there's a 10% chance of rain, that means there is 90% chance of no rain. Okay, hopefully that helps you guys out a little bit more. So 80% of all California drivers wear seatbelts. Right? So 80% of all California drivers wear seatbelts. If 4 drivers are pulled over, what is the probability that all 4 will be wearing seatbelts? So imagine they're on the highway. You're I guess you're a police officer and you're pulling people over, right? So if you think about it, I'm going to write first driver, right? Second driver, third driver, and then fourth driver. So you're a police officer, you follow a car, right? And you stop him. What is the chance that this first driver that you stopped and you look over is wearing a seatbelt? Well, they tell us that the probability that the driver is wearing a seatbelt is 80%. So now, what's 80% as a fraction? 80 over 100. So the probability that the first driver is wearing a seatbelt is 80 over 100. Right? The second driver, again, throughout the day, you stop another car to check on the seatbelt. What's the probability that he's wearing a seatbelt? It's going to be 80 over 100. Same thing for the third driver. What's the probability he's wearing a seatbelt? 80 over 100. And the fourth driver, what's the probability he's wearing a seatbelt? 80 over 100. So we're multiplying, right? 80 over 100 times 80 over 100 times 80 over 100 times 80 over 100. And we're going to get well, if you left it as a fraction, you're going to get 256 over 625. If you want to change that to a decimal or to a percent, it's going to be 40.96%. Okay. Kim wants to roll a die 300 times, right? Kim wants to roll a number cube 300 times. How many times would you expect to land on 4 or 5? Well, right, let's talk about a die. Right, the number 1, 2, 3, 4, 5, 6. This is or, right? It says 4 or 5. So if it comes out of 4, you win, and it comes out of 5, you win. So how many 4s and 5s do we have here? We have 1, 2. So this would be 2 out of 6, right? The probability of getting a 4 or 5 would be 206. But now, you got to multiply that by 300. And we got to get 100. Okay. How many times would you expect it to land on number 1? Well, first of all, let's calculate. What's the probability of getting a 1? Well, the probability of getting a 1 is 1 out of 6, right? There's only one number 1. Well, then take that, multiply by 300. And that would be 50 times. There are 2 red, 5 yellow, 3 blue, 2 and 5 green cubes. Once a cube is taken, it is replaced. So we take a cube. In this case, we put it back. Right? We put it back. So we take 2 yellows. Sorry, 2 reds. No, yellows. 3, 4, 5. 2 reds. 3 blue. 5 green. So what's our total, first of all? The total is 2, 5, 7, 10, 15. So the total is 15. We want to take a yellow. So let me write this. Probability of yellow and another yellow. But we put it back. It says it is replaced. So what's the probability of getting a yellow? Well, the probability of getting a yellow is 5 out of 15. So we're going to take this yellow guy out, right? So think about it. We take this yellow, right? We take it here. Oh, wait, sorry. Take it here. And guess what? We're going to put it back. Right? So we put it back. So when we go for the second yellow, it's 5 out of 15 again. And the final answer should be, times, we get 1 over 9 when you simplify. Not blue. So we want to get not blue and then a blue. And again, it is replaced. We put the marble back. So not blue would be the red, the yellows, and the green. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So not blue, 12 out of 15, right? So, and then again, with this guy here, not blue, let's just take the yellow, for example, right? We take it, oops, let me erase it actually. So not blue, let's say we take a red, right? We look at it, and guess what? We put it back. All right, so now we're going to go for a blue. If you look at it, well, there's 3 blues. Do we still have 15? Yeah, we still have 15. So the total didn't change. So it's 12 over 15 times 3 over 15. And if you simplify that, oops. You get 36 over 225. Yeah? 3. There are 5 science books, 8 math, and 2 social studies textbooks on top of the desk. If you were to randomly pick 2 books, what's the probability that both are science books? So again, right, the probability of science, right, a science book, and another science book. You're not putting it back, right? When you take one, you don't put it back, right? Science. So what's the probability of getting a science book? Well, there's 5 science, right? So 5 out of 15 times, and then you take the book and you put it over here. So now, how many science books do you have? You have 4. And what's your total? Your total is 14. So when you go for the second science books, you have a 4 out of 14 chance. So 1, 5 times 2 over 7, you get 2 over 35 as your final answer. Okay. What's the probability? Which number does the probability, which number show, which number does represent the probability of an event happening? Sorry, let me read again. Which number does represent the probability of an event happening? So remember, the probability is from 0 all the way to 100%, right? As a fraction is the same thing. So this is 50%. This is half. This is 100. Sorry, that's 1. As a decimal, 0, 0.5, and this is still 1. So it has to be between 0 and 100 or 0 and 1. So 9 over 5, if you put that in your calculator, 9 divided by 5, because this is 9 over 5. If you put that in your calculator, and then you multiply it by 100, you're going to get 180%. Is 180% here? No, 180% is over here. So this one, no. 1.34. Where is 1.34? 1.34 is over here. 1.34. Is it inside here? No. Where is 0.004? 0.004 is right, like very here. 0.004. Is that show the probability of an event happening? Yeah, a very small one, but it still does. 250%. Where is that? 250% is over here. Right? So does that show the probability of an event happening? Also, no. Tim arrived to work. Tim arrived early to work 2 times on the last 10 days. What's the probability he will be early to work tomorrow? So, early to work tomorrow. So, there was an experiment, and here is your experiment. Right? He's going to. We saw him going to work the past 10 days, and we recorded the results. So let's go Monday, Tuesday, Wednesday, Thursday, Friday, and then Saturday, Sunday he doesn't work, and then Monday, Tuesday, Wednesday, Thursday, Friday. So think about that. So he was early to work 2 times. So early, let's say he was early Monday, and on Tuesday he was early, which means on Wednesday he was late, Thursday he was late, Friday he was late, Monday he was late, Tuesday he was late, Wednesday he was late, Thursday he was late, Friday he was late. So think about this. What's the probability that tomorrow, Monday, is he going to be early or late? Well, let's look at his history. Well, in the past 10 days, how many times did he come to work early? 1, 2. Only 2 times. But if you change that to percent, you can say, hey, the chance of him coming to work early is only 20%. We have an experiment. Right, here's an experiment. Right, a die, a standard number cube, was rolled. Let's first add them up. So let's add 11 plus 10 plus 4 plus 8 plus 8 plus 9. Enter. So it was 50 times. That's a total. The number 1 came out 11. Number 2 was 10 times. Number 3 was 4 times. The 4 came out 8 times. The 5 came out 8 times. And the 6 came out 9 times. Based on the experiment, what is the probability the next row will be a 3? Okay, so probability of 3, but we have to look at the experiment. So look here, right? In the experiment, how many times do we roll the number cube? 50 times, right? How many times did it come out of 3? 4 times. So there's your answer. Or if you simplify, you get 2 out of 25, right? If Sam rolls a dice 600 times, how many times would you expect to get a 3? Well, probability of getting a 3 in the experiment, and we already did this, right? It was 2 out of 25, and then you multiply that by 600, right? So we're going to go 2 divided by 2 over 25 is a fraction. And we're going to get 48 times. Okay. How many different outcomes are there when you roll a die, toss a coin, and roll another die? So if I roll a die, remember this is a die, right? How many different possibilities do I have? I can have a 1, 2, 3, 4, 5, 6. How many results can I get? So there's 6 results, right? Because there's 6 events that can happen. A coin. Well, a coin is heads or tails. So there's only 2 possible outcomes. And then another die, so another standard die. And again, there's a 1, a 2, a 3, a 4, a 5, or a 6. So there's 6 possible outcomes. And what we want to know the total possible, we're going to multiply these 2. And we get these 3, 72. All right, 3 more questions. How many different pizzas can be created when you choose one from each category? So I think we did this in the class. No, we didn't. So pizza, thin or thick crust. You can choose one from this. You can have regular cheese or extra cheese. And then you can choose one from pepperoni, sausage, or chicken. And then you're going to choose one from olives, mushrooms, and onions. So here, there's two choices. Here, there's two choices. Pepperoni, sausage, or chicken, that's three choices. Olive, mushrooms, and onions, that's three choices. So how many different combinations can we make? Maybe 2, times 2, 3, times 3. So the total number of different pieces we can make would be 36. Okay? Now we got to work on a few tree diagrams later. Sam spun the spinner 80 times, so this is an experiment. It landed on green 25 times. Compare the theoretical and experimental probability of landing on green. So theoretical. And then experimental. Well, if you look at this, let's look at this. What's the probability of landing on green? P of green. Probability of landing on green is 1 out of 4, or 25%. Right? In the experiment, we spun this 80 times. How many times was it green? In the experiment, it was 25 out of 80. So if we change that to percent, right, we get 31.25%. Okay? If we compare, which one was greater, the experimental or the theoretical? The theoretical was greater by a little bit, right, by 6.25%, right? It happened more than we expected. Last question. At the beginning of the marking period, 78 students selected art, 65 dance, and 54 selected film. What's the probability the next student will select film? Let's first of all add them. 78 plus 65 plus 54. 78 plus 65 plus 54 is 197. So, probability that the next student will select film, well, there were 197. And film, how many got film? 54. We can't simplify this, so that's your answer. 54 out of 197. Okay?